Hey everybody, my name is Emmanuel. I'm working with Selassie on an Engineering 300, which is a forecasting class project. So our project has to deal with creating a novel machine learning technique to basically attribute to the machine learning paradigm. So what we decided to do is do a machine learning technique that includes a memory-based aspect. So a bit of the history of this memory retaining machine learning algorithm is we wanted to try to mimic human-like abilities. So generally speaking, a human is able to bring in new information or have an existing information as a normal machine learning algorithm would, use that information to make deductions about identifications about what something is, or any type of information, classifications or regression type models, using old information. And then as it's giving new information, it's able to then draw conclusions. The difference between a computer program and the human ability is that as new information gets input, it starts to learn. So it creates a memory, or it's able to retain information as humans are. And as we try to mimic the human mind, this ability to create a machine learning algorithm that has that memory retaining ability is very useful. DARPA has kind of used a part of that. In 2013, it started a program, according to the website, using a probabilistic programming for advanced machine learning. It has the ability to try to manage uncertain data. And that uncertain data, what it tries to do is understand the data itself, manage the results, and infer the insights. There's not a lot of information on DARPA's websites, which would be understood considering they're part of the Defense Advanced Research organization. And so that's what they have put up on their websites. So secondly is Google DeepMind. Now, Google DeepMind has been working pretty well. We know some of their things that they've been working on. Obviously, using a differentiable neural computer, they use things like next word prediction. We see that in their search algorithms when it comes to Google searches, as well as autonomous vehicles. So they've been doing this more so lately, the last few years. Obviously, this has been working for them much more in the last few years than recently. So some of the reasoning of why we chose this type of algorithm is honestly, after knowing the power of what machine learning algorithms can do, a self-learning aspect seems to be the next logical step. So not only now taking set data and putting it into an algorithm to identify what we want to do now is, as information changes, as the world does change, you want to be able to have an algorithm that will be able to adapt to the changes. Again, going back to DARPA's idea of having uncertain data. And some of these applications really kind of come into a big part of the reasoning why we did this, which was self-driving cars. He uses adaptive learning, drone deployment. So one of the things that we talk about in our paper is if you're sending out multiple drones out of a centralized computer, it has to be able to process information, and then it would be very, very helpful for it to learn this new information and retain the information to then redeploy to all of the agents that are inside that system, as well as this is included with swarm methods as well. So these are some of the applications that we wanted to use that were actually quite helpful, and a big part of the reasons why we decided to do it. Now, the pseudocode. The pseudocode is complex, but I'm going to go through it as simply as possible. This is a very simple method. So in this simple method, we can look at you're loading a data set, you're setting the input values, setting output values, partitioning the training data, partitioning the testing data. And now what we want to do in the main part of it is setting a max value. We initialize it equal to 0, and we run through however many number of iterations you want to run through in different cases. So the cases could be multiple methods of machine learning algorithms. This could be regression models or more advanced machine learning models. And then you're able to, through these methods, teach the algorithm from that training data set and then test the algorithm against the test data. So once you've done that, you can look at a comparing the test data to the predicted test data set to the actual test data set, and defining that as a variable called max. And then you can kind of hop out of that case and then look for an iteration of where max was the highest. And again, max is defined as comparing the test data predicted set versus the actual set. So this is an accuracy from 0 to 1 probability, or a percentage of accuracy. And then what you do is, once you find out what your, depending on the case, which accuracy is closest, you can set that max to that accuracy. So you would now go into and store this best case, because that was the case that you used, the method that you used to find the best accuracy. But if you were just to use one method to find the best accuracy, you wouldn't actually challenge that method the next time you got new data. So what we wanted to do is, once you get input new data, test if that best case was actually better than just a random case, right? A random case or a random method of a machine learning algorithm. If it is better, then continue with this best case. If it's not better, then assign the new best case to that random case that you had chosen. So what we're doing is testing against another method, a randomly generated method, and testing to make sure that it is in case the best case. It is the best case. And then once it's done that, you can end and use that best case that was determined to run the machine learning technique. Now, this is very high level pseudocode. So clearly when it comes to results, there are no physical results. This is a fairly new idea. Even the simplest models can be very, very complex and extremely difficult to implement, and much more than really than you can do, at least at our level, to explain it conceptually. So that is the machine learning novel technique that we've come up with. And again, this is a challenging part, to be able to create a actual physical results from a concept that is better understood just conceptually, because of how new the idea is. So thank you for watching.